good morning, good afternoon, good evening, wherever you're joining from all over the world. Continue to let us know where you're tuning in from. So happy to be here. And we're excited to show you a live demo on how easy it is to switch a real existing application and its data from MongoDB to Oracle and enable GenAI-driven capabilities directly using the JSON data and AI features to expand your app with new capabilities. So we have two speakers joining us from the Oracle team today. So I'm pleased to introduce Beda Hammerschmidt, the VP of Oracle Database, SQL, and Analytics, and Nacho Martinez, Data Scientist Advocate at Oracle. So without further ado, I will hand it over to our team to take it away.
Let me stop sharing my screen and the speakers can take it away.
Beda, would you like to make an introduction, or should I start? Okay, let me start. Just a second. Okay. So yes. Okay. Hope you can see my Firefox. And today, so I think Beda has some kind of problem, but okay, we'll figure it out later. Sorry. So my name is Nacho Martinez. I am part of technology and tech product marketing in Oracle. I have 6 years of experience, and I am 28 right now. And what I wanted to show today is a little bit about MERN application that actually, so MERN stands for MongoDB, Express, React, and Node.js for the application stack. So doesn't matter if you're not a web developer or anything, because we're gonna touch all the components. But since I know that some of you or most of you are focused on artificial intelligence or are really interested, I'm gonna focus my part on that. So before we begin, just to let you know that I will be following some content on GitHub, which at the moment is private, but in the future, we are going to publish this repository, for everyone to have access to it. So, Beda, I think, do you want to make?
Yeah, I was not able to speak because I was not able to unmute myself. But if you want, I mean, you already jumped ahead. That's great. But I can give like a little intro. Sure, why don't we do this?
Yeah.
Before we do into these into the deep dive, so let me just give a little bit of a background here. And can you confirm, Nacho, that you see my slides here?
Yeah.
So this will be just a little introduction on the big picture of what we're doing around JSON document stores, Oracle database, MongoDB compatibility, etc. So one of the use cases that we see with using Oracle database and JSON is that people want to use it like a MongoDB. So we added JSON support about 10 years ago. We have like document style APIs or REST support. But for a couple of years now, we have a full MongoDB compatible API. And what that means is you can connect like a Mongo shell or a Mongo Compass tool to an Oracle database and work with collections as you would do it with a MongoDB server. And one interesting thing is that after we created support for these Mongo collection and Oracle database, a lot of companies decided to actually move the applications that they have written for MongoDB to move them for Oracle. And there's various reasons. I think one of them we will address today, which is about like future workloads, AI. But in the past, it was also just about being able to run SQL, for example, to do some analytics or some bulk processing. So what is important if you want to migrate from one database to another? Actually, here we call it more switching, because with this MongoDB compatibility, it's a lot easier. In the most easiest case, you just replace the connect string and point to a Oracle database instead of a MongoDB database. So obviously, you need the data to remain consistent. You don't want to do a data model migration where you change how your data is stored. And we have JSON collections in Oracle database, so you can really move data from MongoDB to Oracle, even using like MongoDB's own tools, import, export, and your data remains absolutely the same. The data types remain the same, etc. Same as with like your application that you wrote, that they can now run against an Oracle database. So we support the MongoDB commands, the aggregation pipeline, the indexing, etc. And as a consequence, as a developer, there is like no or minimal change. So you can either move existing applications to Oracle. We offer this at a quite competitive price point. So most users also experience that their costs go down by a significant percentage. But even for future applications, you can continue using whatever tools you use, frameworks, Spring for Mongo, etc. Just run it against Oracle. So what does it mean for different roles? So on the left side, we see the application developer. And the big message there is actually not much is changing. You keep using your MongoDB skills, your knowledge, your favorite tools, drivers, framework, etc. So you continue to work with a MongoDB as you've done it so far. But for other roles, people that want to do analytics, BI, AI, etc., now this opens an entire new world. So first of all, you get SQL to access your data. That is very interesting for any analytical or reporting workload. You can join different data, even like JSON data with non-JSON data, spatial graphs. So basically, if you move your JSON data to Oracle database, it's not like a JSON silo. It's instead, you can really use cross-combinational things. You can combine spatial with JSON, you can do graph, etc. And one of the most interesting things that Nacho will demonstrate today is really how to use vector and AI capabilities over this JSON data. Now, the entire stack can run on any Oracle database. So the JSON support is ubiquitous to any Oracle database. So if you or your company runs an Oracle database, you can do this. But we also have a dedicated cloud service called Autonomous JSON Database. And that is has the MongoDB API as a managed service. You can directly connect Compass, etc. And it's priced very attractively. It's cheaper than Atlas, basically. So the math or what we claim here is that you can lower your cost up to 50% by switching from MongoDB to Oracle. Now, in order to make that switch easier, there is various ways how to do it. Like there's obviously the tools to switch or to migrate. The easiest thing would be to say, I'm just running a Mongo export from my real MongoDB server, and then I do a Mongo import or a Mongo restore into my autonomous JSON database, the Oracle database. I can also do a live zero downtime migration through a tool called Oracle Golden Gate. So we've seen some customers do that if their application really has to remain offline and online, zero downtime, and they just do a switch while the application is running. Maybe 20% of people do that. Most people do like a migration over the weekend where there is a few hours of downtime. So this database API for MongoDB, that is a service that translates MongoDB's wire protocol into something that Oracle can understand. And this allows us to run Mongo operations as they are. So it means from an application point of view, all you do is you replace your connect string and you now work with an Oracle database. And it's because it's really supported at the wire protocol level, any tool that is that works with MongoDB, like a framework, Spring drivers, Compass, etc., all these works with Oracle database. We do support transactions, we support indexes, aggregation pipeline in our latest database version 23 AI. So all that is supported. Now, if you move your data to Oracle, you also get all the JSON capabilities that Oracle has. So we store data in a binary JSON format. We don't store it as JSON text or in MongoDB's BSON format. We do have our own binary format called OSIN, and that is really optimized for database access. And that means if you need to quickly access some values inside the JSON, or if you want to do piecewise updates, then we can do these things extremely fast because it's really a binary format designed for database use cases. The other very interesting part here is that now your data, your JSON data is in Oracle, and you have also a large choice of APIs that you want to use. You can obviously use MongoDB's API and SQL, but we also allow direct REST access. So without any more work, you immediately can use REST to access your data. And we also have our own drivers called Soda, which have implementations for Java or C, etc. There's also like a new thing that we don't cover today because here the focus is on AI. That's called JSON relational duality, and that allows you to expose existing relational data as JSON documents, even MongoDB compatible. So let's say you have some relational data in an app that was written, I don't know, 10, 20, 30 years ago. Application is working like a charm, but it's all tables, rows, and columns. You can add some views on top, JSON views called JSON relational duality views. And now the data is immediately accessible via the MongoDB API, but also REST, etc. And I think with this, I think I've spoken enough here about concepts and motivation, and I want to give it back to Nacho, who will show some hands-on demo on how he leverages this.
Yeah, thank you, Beda, for the introduction. So let me know if you can see my screen. But yeah, like, can you? Okay.
Yes, we can see the screen.
So, you know, it's really, really important to understand some concepts about RAG, which is the system that we implemented for this. But like Beda said, we are parting from an already working application that we found on GitHub, and we wanted to show that not only we can, you know, perform a migration and use Oracle database, but also how easy it is to develop an application and increase the functionalities of the application when or after you have done this migration. So how can you benefit by having Oracle instead of MongoDB or just MongoDB, right? So just thinking of the application as an already working application, I will just show you quickly that, you know, I'm logged into my admin panel. So this is like an e-commerce application where it's like an Amazon, but I'm the admin of Amazon. So I can create, you know, an address for my profile, or something simple, right? I live in Spain, so I put the zip code. And, you know, I can add addresses. I can, you know, check out the products that are on my page and stuff. But knowing all of this, I think it's important to give you an introduction of the system, right? So we have this thing called the LLM chat, which is not really important as an implementation because it's just a chat interface, right? So we just created this chat interface so you can communicate with whatever data you have on your database in natural language. So this is just a proof of concept, right? I didn't do anything crazy here. It's just a RAG system connected to a chat interface, and I can ask it questions like, what are some disappointing reviews from my products? And then I will show and I'll explain how the architecture works. But this is actually connected to the Oracle database using Soda, which I have a chapter on that, and I want to show you how Soda works. It's my favorite Python library, probably, to connect to the Oracle database. And then I'll show you what we already have, because the most important thing about creating a system like this that is able to answer questions about your own data is actually the structure of the data and how you structure it. But for those of you who are not really 100% into AI yet, I want to give a quick introduction into how LLMs are and how LLMs nowadays are actually always using RAG systems as opposed to what was before, right? So on day one, right, imagine that we just got started with large language models a couple of years ago, right? And then you wanted to ask a question about whatever, right, to a large language model. So you would say something like, "Hi, I'm Andy and I'm 26," and then the LLM receives the information, and then, with this information tries to output some extra text for you, right? Tries to complete the text, right? So at the beginning, there was no context retrieval. So you would put a text into the LLM, and then it would give you the text plus an extra piece of text that it generated. And it had no knowledge of who you were, any metadata that you had. It wasn't being stored, right? And until some companies like OpenAI came in and said, well, okay, now we need to have some kind of DB system here that allows us to not only store the user's preferences, the age, and things like this to make it more customizable, but also to be able to get accurate answers. And this is the biggest problem with LLMs nowadays, which is hallucinations. Have you heard about hallucinations? Let me know in the chat while I explain this. But the second step was very similar, but an LLM with a RAG system. And RAG allows you, or allows the user, to store the data in vectors, and these vectors are then queried, and then you perform the distance between the vectors to find the closest vectors to what you want. So this is like day two of what we usually have nowadays, right? You ask the LLM system that has RAG implemented and already has some vectors about you and your data on the database. You ask some questions, and then it knows, okay, since this user with this metadata asked me this, then I know that the user 11873 is Andy, he's 26, and then I can, the LLM can pull up all the necessary information to answer the question without hallucinating. So before, let's say that you had the problem because, you could say something like, George Washington was born in Texas, right? And that wasn't true. But there was no way for the LLM to verify this information, right? It would just believe you that, whatever you put on the LLM was well-intentioned, and, it was correct. And then it would try to come up with some additional text like, oh, and he was born in 1881 or something. But starting from the premise that the input that you gave it was correct, right? This is the most important distinction. With RAG, what we want to do is to vectorize all the data, all the text data that we have, and use these vectors to then plug them into the chat so that the users can actually arrive to these conclusions, right? So let me, here I have an example, a more detailed example, right? Of something I tried to do a while ago. But this shows exactly all the components that need to exist in a RAG system, retrieval augmented generations, which kind of stands for like a better way to answer questions. So let's say that I'm Heather, or let's put here my name just for the sake of it. And I'm looking for advice on courses for health law. Let's say that I'm a student at the university, right? And then I have this kind of user interface, which is the chat in our application. And we already have some metadata about the user, which we are passing it, right? So there are some components. First, the user interface, which is the least important part of all. And then we have embeddings, which an embedding model is the thing that transforms the text into meaning, into numbers that are actually used then to be stored in the vectors, right? So at the beginning, you have text, then you have embeddings, which are really, really big vectors, usually 100 to 500 dimensions in size, right? So you have a multi-dimensional space with all these vectors, right? And you are essentially computing the distance between the vectors, right? So first of all, you use the embedding to create the meaning of the sentence, and then you will use these embeddings to be stored on the database. And the embeddings, they don't look very well. They don't look very pretty. Like, this is what I came up for this solution. Specifically, I am embedding all the reviews, and I'm storing the matrix. I'm storing the vector directly into the JSON native collection in Oracle database. So all the addresses, whatever I choose to create, it shows up on these collections, right? But what you need to understand is that we vectorized a JSON object, right? And then I just put the embedding here as well. So whenever I ask a question about the reviews, which is the collection that I'm using, right? I will be able to get information about the title, the ratings, the review text, the status, and all these things. And I did this over and over and over for all the reviews on the e-commerce application. So essentially, we vectorized all the reviews on the app. But now that you understand a little bit better how vectors actually are useful to retrieve the information, whenever we get the most similar vectors, then we can build the answer for the user, right? We get the result vectors, and then we just send it back to the user. So the results of the LLM are shown on the chat interface. But so now that you have this, let me talk to you about the architecture for this solution, right? So we have the Express React Node and Mongo application, which we already migrated to Oracle. And then you might say, well, how did we perform this migration? Beda mentioned that you have Golden Gate, that you have some shell scripts, right? But this all becomes available because on my Oracle database, I'm on my OCI account, right? I can see all the databases that I have, and I do have this one, which was created specifically for this demo and for showing this. We have a thing called tool configuration here, which allows you to activate like plugins on the database. So for example, if you are a web developer, you might activate Apex, which is Application Express, which is a low-code or no-code application framework that allows you to create websites directly connected to the database. And we have many like this, right? We have database actions, which is already enabled, which allows me to connect to the database via web, right? I have here lots of things to use. If I also have relational tables, whatever, I can take a look at through the database actions. But the plugin that I want to talk to you about, and this is how this solution came to fruition, is that we enabled the MongoDB API plugin, which is free. And what it does, it enables all the MongoDB compatible clients and the drivers to allow them to connect through this MongoDB URI or URL, like you usually do with Mongo Compass and whatever. So let me just show you quickly, if I can. Oh yeah, sorry. So once we enable this MongoDB API plugin, then we already have the connection. So I just get this, I replace the user and password from my database credentials, right? And then I'm able to connect to this database with Python. And for Python, I use PyMongo at the beginning for connecting to the database. But you also have other libraries and frameworks to connect to the database, which I like more. And I'll let you know how this implementation is, right? But now that you have kind of like an introduction to RAG and why RAG is important, right? The most important thing is to vectorize the data. And so once we have our data vectorized, we can ask questions about this data whenever we want. And we make sure that, you know, the model will not hallucinate, or we will likely considerably reduce the hallucinations of the model because we're actually providing it with real data. And this is this is the most important, in my opinion, the most important feature of retrieval augmented generations. It eliminates hallucinations, right? So just to give you a quick recap of the burn stack, right? We used to have MongoDB. Now we have Vector as database, right? We have the React UI, or the user interface, to chat with here, the LLM chat, right? We have Express API for all the endpoints. And this is, you know, if you're particularly interested in the web development part of it, you can check out all the code that we do have, and we already have. You'll be able to check it out on GitHub. But all the endpoints are actually implementing one feature of the application. So let's say that you want to, I don't know, list or take a list of all the brands available in my store. Then I have an endpoint which will solve this problem. And you might say, well, this might be a little bit redundant, right? We might have 5 features that are very similar in between them. Like, why do I need 5 different things to implement each one of them? Usually, this is very, very beneficial when you are working with multiple people and you don't want to, you know, you don't care about others' work. You just care about your function working. And this is one way of developing code, and it's usually agile. This is the microservices approach. I don't know if you have heard of microservices, but microservices are like the most isolated part of code that you can do to implement a function. So let's say that you want to, I don't know, create an address, right? Then without worrying about whatever was before on the application, you create an add address function, and you know, you can take the variables from your application and stuff, but you just have to make sure that your code runs alone without needing the intervention of other endpoints and stuff. And this allows many people, teams of hundreds of developers, to develop applications without, you know, having 300 conflicts or 500 lines of code that are being modified by multiple people, which is a big problem in software development, right? But yeah, so the Express API is using microservices. So when I want to implement this with AI, I will implement, and the implementation of this is on the GitHub, but we do implement a new microservice to allow the functionality to chat, to retrieve information from the database, and then the whole thing that we explained. But this is kind of the layout, and let me show you the advantages of having a system like this, right? So I thought of the following, right? We want to expand the functionality of the MERN app without in an isolated manner, like we said with microservices, right? So we have the MERN app on one hand, we have the React frontend, the chat, and let's say that this is like a sample conversation with the model, right? I make a request to the chat, right? I make an API call through the Express API endpoint that we developed, and then this goes and takes a look at whatever we implemented. So this is the middleware. This is the part that implements the microservice. I implemented this on Python. You can actually develop many microservices in many languages as long as they are available, right? So this is one of the other advantages of having microservices. You are language agnostic. You can choose your libraries. You can choose your programming language, your preference. I'm a Python person, so I chose Python to implement this. But many of these things that were already implemented on the application, they were implemented in JavaScript. But since I said, well, this is a microservice architecture, I will just implement my part on Python and then just do a redirect from one endpoint to the other, right? So my question to the chat, which I believe was something like, what are the most disappointing reviews on my website? This goes to the rack service, and this does a redirect to the Node.js and Express API. And both of these combined, they go to the Oracle database and perform the vector similarity search that we were mentioning before. And with the context, we build the context. We build, I think I am retrieving the 5 closest vectors to the original user's question. And then I'm getting those vectors and I'm using the input from the user plus the vectors to build the answer. But architecturally, this thing is actually running my LLMs. And you will say, well, why is this apart? Like, why is this outside of the MERN app stack? Well, following microservice implementation, I thought, let's isolate everything. And it's actually going to be better because I can create like a kind of like a command and control system for large language models separately from whatever is running the MERN stack application. So you can have on a server your MERN app running for your users, and then you can have another server which is completely isolated for the AI part. And I believe this has a lot of advantages. One of them, if you have an issue with the AI parts, you don't have to shut down your whole application. So maintenance is much faster. Developing code is also much faster because we're using microservices, and we are using Ollama for this. Ollama is, for those of you that don't know, it's an open source framework for launching however many models you want, right? So the idea is that I will make requests to the LLM, and then I will also get the vectors and send them with my request so that the LLM has all the context. So the functioning, by isolating, you're not destroying the functioning of the LLM. You can also have distributed RAG systems. They don't have to be local. They don't have to be close to your data if you want, as long as they are. For example, if you create this compute, if you're specifically worried about, for example, let's say the security of your data leaving through the internet somewhere, you can create, a compute that is running the MERN stack application, right, in the same subnet as the compute. So you will put both of them into the same subnet and then configure the security rules and whatever you need to make it scalable. So really, the data doesn't necessarily have to leave the cloud, right? This is what I mean. You can have multiple computes for this, even if you wanted to scale up. Another advantage is that you can take the AI component, which is usually the most GPU intensive part of and the most expensive also, and you can scale that up independently from the MERN application. So a MERN application might need CPUs, but for parallel processing, which is what we usually do with rack systems, we do need GPUs, right? So imagine that your new Amazon application or your e-commerce application suddenly becomes, or unexpectedly becomes, like top 3 on the App Store, right? You might have to scale up to 100, maybe 100 times more GPUs than you had before. This would not be possible if you weren't using, well, a cloud provider, first of all, but also a distributed architecture. You would have to shut down the whole application to just add some GPUs and then just rerun everything, right? So that is one of the many advantages that MERN has, the MERN application stack has. It allows easy development, a lot of flexibility, and a lot of scalability. So just wanted to let you know about the implementation a little bit. And this is how we did it, right? So first of all, we have some kind of collection architecture, and I think that this is the most important part, right? So remember here that, sorry, somewhere here, we had some kind of metadata about the user, right? So this is kind of how we need to think of the problem. However you structure the data and it ends up on a vector, that will unlock all the power of your data. And what I mean by this is that the data is the most important part, and you need to worry about how to structure it in a way that whenever you query something in the future, you will get a consistent response, right? So storing things like the name of the user preferences are a good example here. But what kind of metadata do we have for our reviews? Well, for the reviews, we have something, I mean, these are just sample reviews. So they have the date, you know, created at some point, the rating 2 out of 5, product ID, and whether it's recommended or not, the title, and the review text, right? So someone says on chat, what should we call the MERN after migrating from Mongo to Oracle? You could call it ORM, but I don't know. You can call it whatever you want. And also, being a multi-model database, how does Oracle Database 23i differ from a true vector database, especially for AI RAG operations? Well, perhaps Beda is more equipped. Perhaps we can take this question for later, and Beda has more
Sure,
you know, things to say about this. But what I will tell you is that one of the capabilities that I like the most as an AI practitioner or as an AI engineer is the possibility to have kind of like a dual view, where, I mean, with JSON duality views, where you can actually not only see the data here on JSON, because you would be able to also see the data in JSON on Mongo, right? But also see it in relational. So if you have, if you're working with an application that, you know, has multiple people working on it, there might be some people that are more accustomed to using vectors, and some other people that are like stickler for the rules and stickler for the structure of the data, and then they just go for relational, right? So you can actually provide both of them at the same time with JSON duality views, which is one of the features of 23i, but there are many more. Like you have built-in vector similarity search. You already have built-in functions to do that. Built-in embeddings, which you can authenticate directly with, I mean, you have Grok available on OCI. You have Llama 3, Llama 3.2. You have multimodal models, and you can call these models directly in the database with an SQL procedure. So you can embed things with built-in functions. You can create vectors and perform similarity search with built-in functions, and then you can also modify the functions, the vector similarity search functions. And this actually was a great question because it brings me to the next part, which was I was going to show you how we do cosine similarity search in Python, right? I mean, we're doing the implementation of similarity search, but you can actually choose and customize which similarity search functions. If you want L2 distance, Euclidean distance, all of them, they're available for you and they are built in into the database, which I don't think many databases do, at least for the moment. Probably it's going to change in the future, but that's my take. Probably Beda can give you more info in the future. So just for you to understand that we have we make a lot of thought into how we structure the metadata, and then the embeddings. The structure that we reviewed is the text and also the embeddings. And since we are using this model, right, the mini-LM L12 V2, this is a sentence transformer model and embeddings model that creates 384 dimensional embeddings. So this means that each vector with embeddings in our database has 384 different values between -1 and 1. And this is actually what, the LLM sees. It only sees the numbers instead of the text. And then how do we perform like document storage with vectors? We just generate embeddings for the reviews, and then we just insert them with Soda. Then we have the vector similarity search, so creating the embeddings and then performing the distance between the two vectors, like Suresh said in chat. And you can modify, implement whichever functions. You can override the original functions that are there already, or you can create your own with SQL. It's up to you. I'm a Python guy, so I just said, well, let's do cosine similarity, right? But you have complete control over this. And then this is the one thing that you do need to take into account, is that since we are doing this AI processing in the database, we are actually taking, if you remember, we're taking all the reviews and then we're creating embeddings for each one of the reviews. So this is done in batches, or this is done like programmatically, because since this is a new feature and I wanted it to be completely isolated from all the other functionalities of the application, I isolated it completely, right? So all the reviews that didn't have embeddings, you need to put embeddings in so that they are queryable or they are askable in the LLM chat. So this has to run every 24 hours. However, perhaps you can even trigger it to update your reviews after a new review is created. Just create it directly with the embedding. But just remember that, for large data sets, if we have hundreds of thousands of reviews, we might need to do this every day to just include more data in. Oh, and this is one of the other advantages, which I forgot to tell you about RAG, is that you can just keep adding vectors without having to retrain the LLM, right? Which was what we needed to do a couple of years ago, was actually you need to include a new PDF into the training data, that you need to retrain it wholly, which is a terrible practice, because training a model takes hundreds of thousands of dollars, if not tens of millions of dollars nowadays. So with RAG, you can just increase the amount of data that the LLM has available without having to worry about, retraining or spending tens of millions of dollars. Right? And the last thing I wanted to talk to you about is, we already saw many of these, but the complete RAG pipeline is the user, and I'm just showing some code snippets here so you see that all of this is implemented. A way for the user to make a query, right? So we create an endpoint following the MERN stack. To perform vector similarity search, we are taking the 5 most similar documents, which you can choose the number and customize it. to build a little bit of context. So you get the user question plus the context, the vectors that were retrieved from the database. And then you need some kind of prompt engineering to make the LLM answer you in the way that you want. So I made it very restrictive because I didn't want the LLM to hallucinate or give you, this is a demo. So things usually go wrong on the demo. So I just made it very restrictive so that whenever we get an answer here about, disappointing reviews or whatever, we are actually exactly showing what's on the database, not, trying to avoid at all costs hallucinations from the model, right? And then the response generation, I am using 5.3, which is a great model. It's open source. You can download it and pull it with Olama, and then you have access to an LLM. So this could be your own, your own framework. Instead of using a paid model, you can use your own by deploying it, right? And then you can also configure some hyperparameters. The temperature, the lower the temperature is, the more factual responses, the less hallucinations there will be, because it will be less creative on the responses, right? And just to conclude, I wanted to show you my favorite Python library to connect to Oracle database, which is SODA. SODA stands for Simple Oracle Document Access, and it's just a way to chat with, in Python. I'll show you here, but you get these SODA operations, and without going too much into detail, you get all the functionalities of what you would expect on a JSON manipulation or JSON library on Python, right? You can find documents by key or by key. So you can choose whichever column of a JSON document you want to query upon. You can find, you can also apply filters with some criteria, and then you can also remove and replace. And the thing is that SODA will actually ensure data consistency. And perhaps, Beda, you do know more than this, so I will give you a couple minutes to talk about data consistency and JSON duality views and whatever else you want to mention.
Yeah, let's do a quick time check. We got, I think, 8 minutes left, right? So yeah. Are there anyone that wants to unmute themselves or any questions? I think there is a question regarding oh, let me ask you this, is there anything else you want to show, Nacho, before we go to Q&A, or does this
just for everyone to know that all the things that I spoke about are here, so all the implementations are on the GitHub, and that these will become available shortly.
Okay, perfect. So people can play with it, and I think one important piece of information is also that our autonomous database, like the Oracle database in the cloud, has a free tier. It's actually the one that I'm using myself. So you can have up to 2 databases, and you can choose between version 19 and 23 AI. And this has no cost. If you sign up, it's the always free tier. There's a bunch of questions here regarding performance. It's kind of scrolling by. Let me scroll back here. MongoDB. So, what performance implications will there be for common MongoDB usage patterns, small updates, high write, indexing, and so on? My experience after doing several, or being involved in several dozens of migrations, is that MongoDB use cases are typically index-driven, and if you have an existing application, then you would just create the same indexes and it would perform pretty much the same. Now, where MongoDB is not very good at is kind of really reporting analytics. Usually, if you have the aggregation pipeline, that's also supported by indexes, but Oracle has a lot more performance tuning capabilities. Like our autonomous database runs on Exadata infrastructure, where we're actually able to push down filter predicates all the way down to the storage controller. So you will see that a lot of analytical queries are much, much faster even without indexes, because an index also requires some maintenance time during inserts and updates. We also have materialized views. So there's like the usual thing with Oracle is like there's like 7 things to tune performance, and it's a bit more complex to find an optimal configuration. But if you just have an existing application and you want it to behave as is in terms of latency, response time, etc., it's pretty easy. You just move it, make sure the indexes are there and are used, and it behaves the same. Now, if it comes to updates, I think there was another question, frequent small updates, high write put. We actually do some benchmarks, or actually was a third party that did a benchmark on the industry standard YCSB. This is like a pretty write heavy or update heavy workloads on small to medium sized JSON documents. And there we actually were a bit faster. And the reason is that Oracle database can handle concurrent workloads pretty well. So if you have a lot of writes and deletes and updates happening at the same time, we can scale very well at these concurrent workloads. So from a performance tuning perspective, it's not really that different, and it does not behave really in a way where that would be a concern of moving. I think the important message here, and I think Nacho made that clear, is really if you want to develop these AI applications, it's really more like a platform that you need. It's not so much that you say, hey, I want to consume my data as JSON, because in some cases you might want to do it as JSON. In other cases, you say, hey, I need to view my data differently. Like maybe the application consumes the JSON in a certain shape or format. But for one other use case, maybe some AI workload, some machine learning, etc., I may want to have the data in another format. And I think this is where a multi-model, or what we call converged database, is a lot better, because you can have all your data sources or data models together. So you could say, hey, I have a query that has not only like an AI vector query, but it's also filtering on some other attributes, like maybe a date range or a price range, etc. So these are queries that are not pure JSON queries, not pure vector queries, not pure spatial queries, but they may be a combination of all 3 or 4 or 5 different data models. Or maybe your data sources are sitting outside the database, etc. Right? Or maybe you need access to data that an existing application has already collected over the last years. And this is, I think, where a data platform is quite important. So I think in this AI world, there will obviously be a lot totally new applications, but I think people will also go back to existing applications that are running for years and say, how can we improve them? How can we make the search result better? Or how can we make fraud detection better? And a lot of that data sits in Oracle database. And you may decide, hey, I want to use JSON as a development paradigm. And this is where we could say, hey, yeah, just use duality views, make your data accessible as JSON through the SODA drivers that Nacho showed, or Mongo API or REST, and just combine these different features in your application, and not be limited to say, hey, I'm only MERN, or I'm only this, or like, we don't want to be a silo, basically. I'm not sure, do you see any more questions, or Tara? Anything else we want to address here? We got a couple minutes left. Maybe share some wrap-up slides here.
So there is one more question about, do you have any examples of prompts that can be used for SODA access to vector databases? And if you're still here, Fred, I'd love to get some clarification on that. If you mean, just prompt engineering ways to make the SODA access more convenient, I can, I mean, perhaps because we're running out of time, but I will stay here. So if you're still here, let me know and I can answer that question better.
Yeah.
In the meantime.
So yeah, these are some resources. You could take a screenshot of these. I don't know if we send them out after the event, and we also ask for your feedback. I don't know, do we stop hard on time, or can we go a bit over if there are more questions?
Yes, totally fine. We can have a few more minutes for more questions. And by the way, if you prefer to ask questions, speak to ask questions, feel free to raise your hand. Actually, I already turn on your microphone, so you can unmute yourself to speak to ask questions.
Yeah. So let me answer Fred. In the meantime, if any of you have more questions, just keep putting them in chat, and we'll stay here for as long as we need, or until they don't let us anymore.
Yeah.
So let me show you examples.
Are there any more questions?
I think we answered the outstanding ones, but yeah, keep dropping them in. We've got some time.
Maybe, Len, let me just do these recap slides very quickly while people are maybe typing their questions. So I think the big high-level aspects we wanted to convey is that it's easy to switch. Like if you use MongoDB, you can move these to Oracle for existing apps or new apps. And what it basically means is we make JSON development easy. And that does not limit you to MongoDB API, not just showed Soda, or you can do that with REST. We really try to be like an open system, open in terms of what kind of data models you can process. So you can join JSON with relational, spatial, etc. Your data can reside inside the database or an object store. It's actually quite cost effective. So usually people save quite a bit of money when using Oracle database. And this could actually be also a good thing. If you have like a limited IT budget and you save money by going to Oracle, that frees up things that you could use for new AI projects. And the other thing is, as part of being a converged database where we added a lot of capabilities around AI and vector, those capabilities are all working with JSON and Mongo API. So you can really, you get a great data platform. Quick slide on migration. There's even like a Golden Gate tool or a container you can use with a UI to move data from MongoDB to Oracle database. And that really makes these migrations easy. And this is also free. Like everything we've shown here, if you want to try it out or prototype around, you basically can use our free versions, free Docker images, free cloud services, etc. Good. I think let's see if there's more. Any more questions here?
Can you put the link for the Oracle Cloud DB link in the chat?
Yes. Was that the one on the last page?
It was the one, the oracle.com/ I think it's /free, right?
Tara, do you know which link? So there's like get started with Oracle 23 or try Oracle Cloud Free. Yes, there is this one, I guess. I don't know, did it? Yeah. Try LCI.
Oh no, but he might mean this one. The one for the container, the 23i container.
Oh, you mean the the Golden Gate?
Might mean the not Golden Gate. Oracle DB 1 GB container, free container instance that you can deploy.
Oh, got it. Yeah, I would have to Google that. I don't have that link handy. Let me see if I can find that.
I think it's the oracle.com/database/free, where Gerald is. There's on that side. Yeah, you get the ability to experience Oracle database up to 2 CPUs and 2 gigs of RAM and 12 gigabytes of storage for user data. And you can use that for free. I mean, you can install the container. We have a container for that.
Yeah, got it. Oracle data. Yeah, it's Oracle database/free. Yes.
Yep. I've been dropping them in the chat. Sorry, I realized I was muted, but I put the free tier one and the database 23i one in the chat again, so that you have it, Chris.
Good.
It looks like there's one more question on how is consistency assured if they're mixed environments during migration or afterwards.
So the question is, how is consistency assured if there's a mixed environment? Some data still in MongoDB, some in Oracle during migration or afterwards. So if you do a offline migration, which is usually the simplest one, if you don't have massive amounts of data, you would export your entire data while there's no changes, and then you would import it to Oracle. So this would be accompanied with some downtime. But we can also do a zero downtime, or what we call online migration, using Golden Gate. And that is usually the case if you have either very large amounts of data where it would take like too long, the downtime would be unacceptable, or if you have 24/7 access. And the way it works is that we have a product called Golden Gate, which moves data and it tracks all the changes that are still happening. So they're basically mining the log, the MongoDB, I don't know if they call it redo log or like replication log, and they know about all the changes that are happening on MongoDB as they migrate. And we've had cases where the data volume was so large that it took like 2 weeks or 3 weeks to really move the data as changes were happening until everything was moved, because you also don't want to like overwhelm the MongoDB database. It has to remain reactive. But at some point, you basically have moved all your data. You're totally up to date. Now, every change that happens on Mongo then happens at the same time on Oracle. And that is the point where you then switch over. And you say, at this point, the next connection that comes doesn't go to Mongo, it goes to Oracle. And then you have a fast switch over. So that's what we call a Golden Gate live migration, or zero downtime.
Great. Any last questions before we wrap up here? All right. I just wanted to make a note too that we'd love to hear your feedback on today's session to help us improve our future sessions, and also that we have another session coming up. So I'm dropping those in the chat right now.
Yeah.
All right.
Yeah. Thanks
Thank
a
you,
lot,
everyone.
Okay.